Hey everybody, this is Miss Levin and I'm here to teach you about mass mole or mole mass equations in stoichiometry. If you haven't looked at the mole or mass equation videos that I've posted on this YouTube channel, please do that first because I specifically reference what we do in those videos. Okay, so the way that these mass mole or mole mass problems are different is here we end up seeing that either the given or the unknown are in different units than the other. So one is going to be in grams and the other one's going to be in moles. If the given is going to be in mass, and the unknown is going to be in moles, it's going to be a mass mole problem. If it's going to be the other way, where your given is in moles and then your unknown is in mass, then it's going to be considered a mole mass problem. But basically, we are doing the same thing that we saw kind of as a mashup in our mole-mole conversions and our mass-mass conversions. Okay, so please make sure that you check out those videos first if you haven't done so, because I think it's a little bit easier to learn mass and mole separately before we kind of mush them together. Okay, so what we see is that if you are given a mass, what we always have to do is get to moles. All right, so you use your molar mass in order to convert, then you end up using your mole reactions. In every stoichiometry problem, you will always use your reaction ratio, which is in the units of moles to moles. All balanced equations, okay, are measured in moles. That's why mole money, mole problems, we have always that unit of mole. Okay, and then if you are in moles with your moles unknown, you stop. Okay, if your conversion factor or your problem asks you to go to grams of your given or your unknown, I'm sorry, I misspoke. Okay, then you would do that final step. So I think it's really nice to see the two game plans of what we're looking at. Okay, they're going to look really similar to our mass game plans. Okay, so for this first one, we're going to see that you start with your given mass. Okay, then you use your molar mass of your given to convert between the grams of your given to moles, and then you use your reaction ratio. Okay, this is going to be used for a mass mole problems because you are going to stop when you get to moles of your unknown. Okay, the opposite is going to be true for a mole mass problem. You would start and be given moles to start off with. Okay, so this is going to be your mole mass problem, conversion game plan. Then you use your reaction ratios. You always use your reaction ratio in stoichiometry. And then you end or stop when you get to grams of unknown. Okay, so sometimes you need to just, cut out this last step of a mass problem or cut out this step over here of a mass problem. So you have to really understand the relationship between grams and moles and grams. Okay, so if you haven't looked at the mass or the mole videos, be sure you do that before you go any further. Okay, so next. All right, here is our similar sample problem that we had before. All right, we have to balance out our equations first. 4 aluminums and 3 oxygens give us 2 aluminum oxides in the synthesis of aluminum oxide. And this problem says how many moles of aluminum do you need in order to make 15 grams of aluminum oxide? Okay, so 15 grams of aluminum oxide is my given. All right, And then we want our moles of aluminium as our unknown. Okay, so since I am given grams, okay, this is a mass, and since my unknown is in moles, this is a mass mole problem. So with this, our game plan is going to be to start with our given mass, then multiply by the molar mass of our unknown, molar mass of our given, and then use the reaction ratio to get to moles of our unknown. And then we stop there. So just like we saw in the mass problems, we need to convert the grams of aluminum into moles of aluminum oxide. So we do that by using the molar mass of Al2O3. So bust out your besties, the periodic table. Hi, friends! So we have 2 aluminums, both of which are 26.98 grams per mole. We have 3 oxygens, which are nicely rounded up to 16, giving us a molar mass of 101.96 grams per mole. This is the molar mass of our given. Okay, and then we are going to figure out what our reaction ratio is going to be. Okay, all balanced equations are in moles, so these numbers represent those quantities. We have 2 moles of aluminum oxide for every 4 moles of aluminum. 2 moles Al2O3 for every 4 moles of aluminum. Okay, this is our reaction ratio, which you always get the reaction ratio from the balanced equation. Okay, so let's plug it in, follow the game plan. Let's see what we get when we start putting this stuff in the right spot. Okay, so first things first, start with the given mass. The given mass in our problem is 15 grams of Al2O3. I know I have 2 conversion factors I'm going to have to use my dimensional analysis with, so make 2 blank lines. Okay, and then arrange the molar mass of my given in the correct spot. Okay, so it's 101.96 grams per mole. If I start with grams here, I put 101.96 grams of aluminum oxide on the bottom, 1 mole of aluminum oxide on top. What cancels out? Come on, you know this. Grams and grams of Al2O3 are going to cancel out. Now I can use my reaction ratio. So my reaction ratio is going to be the 2 moles of Al2O3 for every 4 moles of aluminum. I get them from my balanced equation. And then I put Al2O3, if it's on top here, I put 2 moles Al2O3 on the bottom and 4 moles Al up top. So what cancels out, you say? Moles of Al2O3 and moles of Al2O3. Now, am I at the unit that I want to be? You better believe it. I want moles of aluminum. Guess what? I'm in moles of aluminum. Everything canceled out except for moles of aluminum. So how do I solve this? Grab your trusty calculator and let's see how we put this whole thing into the calculator correctly by saving time. Okay, if it's in the numerator, you multiply by everything in your numerator and divide by every denominator. So I would plug in 15 times 1 times 4 divided by 101.96 and another divided by 2. Make sure you try this. Push pause. Go get a calculator. Make sure it's a calculator and it's not your phone because you need to be able to use all of your scientific notation eventually. Okay, so go get it, go try it, see what your number is. I'll wait. Okay, you're back. And you should plug it all in and get 0.29 moles. Okay, this has 2 sig figs, this has 2 sig figs. Don't worry about the sig figs in any of your conversion factors. Technically, this is 4.00000 repeating and 2 and 1 repeating with a infinite number of sig figs with that. Okay, so to review, a mass mole equation, you start with grams and you end with moles, hence mass mole. But you always, 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 in stoichiometry, use the reaction ratio. It's all based off of the reaction ratios in every single stoichiometry problem. The problem that you need to look out for here is using the molar mass in order to change these grams into moles before you use the reaction ratio. Because don't forget, reaction ratios are also always in moles. Okay, so it's very rarely that we say the words always in science, but this is always. Always and forever. Okay, so to review, given mass, okay, 15 grams Al2O3, use the molar mass of the given, do your side calc in order to figure out what your molar masses are. You should be pros from the chemical quantities chapter. And then you want to range, if you have 15 grams of Al2O3, you're going to have 101.3 grams of Al2O3 on the bottom. 1 mole of Al2O3 will go up top. Then you use your reaction ratio, which is from the balanced equation. Okay, it's always in moles to moles, and you want to arrange that so that your units cancel out. If you have moles of Al2O3 up top, you put your 2 moles of Al2O3 on the bottom, leaving moles of aluminum as your unknown, uncanceled unit, and you get your 0.29 moles of aluminium. So more pro tips, okay? In a mass problem, this will always be your given mass. This number, this position in the denominator will always be your given's molar mass. This numerator here will always be the given 1 mole equivalent to the molar mass, because this is how many grams are in 1 mole of Al2O3. And step number 3, your reaction ratio. Your ratio will always have your given in the denominator, and your reaction ratio up here will always, always have your unknown ratio from the equation in the numerator. Okay? So those are pro tips. Always look for those things in those positions. Okay? In a mole mass problem, you would cut off here, and then you would just add in the molar mass of your unknown here, because you would be starting in moles of your given. Okay, so good luck. Let me know if you have questions. Make sure you check the other videos of mass, and mole. And that is an example of a mass mole stoichiometry equation. All right, good luck. May the moles be with you.